All right. Well, it looks like we have a few of you on. I don't want to hold us up too long today. I'm not sure how much Diana is going to be sharing with us, but welcome to Reline Live. I'm excited to be bringing these back to you guys. I'm going to continue to try and do them twice a month. So for those of you that do want PDH credits, just email me afterwards and I will try and get those to you. I will just be sending you certificates that you participated. This one's totally new. I normally have some input and some experience in the Reline side of things, but with Diana's presentation, I am going to be also learning with you guys. So please use the Q&A box or raise your hand. We want to make this interactive as possible. Diana kind of wants to give us a different side of Trenchless since she doesn't necessarily work in relining as an engineer. So welcome, Diana. I'll let you give a little bit of your background and thanks for joining me this morning.
Thank you. Thanks so much for having me. I work in the other side of Trenchless, the new installation side. So let me make sure I can advance here. So yeah, unlike rehab and relining, we're typically installing all new pipes. So that can involve a variety of technologies, auger boring, HDD, which is horizontal directional drilling, and those two technologies are represented in the pictures you see here. And there's also pipe ramming and microtunneling and pilot tube and shield tunneling. So there's just kind of a lot of variety. And
We might have
in
to
a,
do another Reline Live for the other ones you listed. Some of those I've never even heard of.
I know, yeah. Well, and in addition, there's all these kind of hybrid methods always coming. Like, for example, pilot tube guided boring
I've never heard of
is
that.
this thing now, but it was kind of a hybrid thing for a while that just contractors especially are always innovating and manufacturers right along with them. So um, my background is in geotechnical engineering. I was what I call a classic geotech for a few years, doing bridge foundations and slope stability calculations and stuff like that. And then I started transitioning, I guess, into trenchless. But like Cassie said, my angle is a little different than a lot of you are probably more used to. So I do new installations. Um, I also will design pipe bursting, which is probably something you guys are a little more familiar with, and it's kind of a straddling of the two worlds, maybe pipe bursting. It's kind of new, but also kind of rehab. So yeah, please ask questions. Hopefully some of you are a little familiar. If not, great, and I'll tell you whatever I can about any of these new installation methods here. I'm going to tell you about.
We had one person say that you're kind of echoing, but I muted myself. Can anyone tell me if that got better when I muted myself? Because I just wondered if it was that both of us were on an open mic. So maybe that made it better. I was waiting to see if anybody
This
and
might be
or raise your hand if it got better or if it's still the same once I was muted. It didn't change.
change.
Maybe if you turn your speaker volume down just a hair, it won't echo so much. And then I'll go back to muted.
Okay, hold on.
Michael, let me know if that makes it a little better because someone else said it sounds good. So it could be a speaker maybe on your side too.
Turn my
That sounds better. I heard a little bit of cracking, but I thought it went away when I muted myself.
Okay.
That
Let me
sounds
know if
better.
it's fair
Okay.
while I turn it down just a hair. Sometimes it's hard to this microphone sometimes is like not working. So you have to turn it back up. Yeah. So I have a couple of projects to tell you about today. Let's get back to the slides. Here we go. So the first one is so this was a big project. It's kind of more of a program, Willamette Water Supply Project, and it's been a big project in the Portland area here for the last several years. And so the goal of it is to bring fresh water from I believe, oh shoot, I'm gonna mess this up. I believe it's the Willamette River, and bring it to a lot of the area like south of Portland. There's a lot of residential area there, and especially developing all the time. So It's a big pipeline. It's a 76-inch, I believe, pipeline.
I don't see your slide. I think you're still stuck on the first one.
Uh-oh.
You might have to start your presentation and move through them.
Let me back out a bit first.
Because I see that you have 16 slides. There you go. Now I see it.
Okay, maybe we'll just do this method. So this is what I was showing you before, the new installation methods. And here's this particular project. The final product pipe is 60 or 76-inch. I can't remember right now, actually, but the crossings, the trenchless crossings for going across roads in particular, are 84-inch steel casings. And this one was kind of a short one, honestly. So this is not like a big award-winning project. This is, I told Cassie, it's kind of like a standard auger boring project. It's not too exciting, but I thought it was a great one just to showcase this method, because this is kind of a typical thing that any auger boring project would entail.
I know you have a lot of pictures on this one, Diana. Can you explain to us, since I am literally never done or seen auger boring, kind of what that methodology looks like? Because this is under a road, right?
Right. So yeah, it's under a road. You can see on, I'm gonna try to go big again. Do you still see the slide now?
Yep, I see the yellow pipe or machine.
Yeah.
Yeah.
Okay. Do you see the picture on the left as well?
Yep.
Yeah, so it's going under a road, and it involves two shafts or pits. It's kind of an interchangeable term in this case. Not too deep, as you can see, 2 trench boxes deep, and you start in one shaft and drill over to the other one, essentially, just in really simple terms. But I'll show you some pictures that show you some of the details. So this is yeah, the yellow machine is mostly just an empty pipe, and I'll show you. Maybe I can just show you now. That top left picture is kind of a funky little, I tried to get a picture like by putting the camera like up between a little gap, but you can see at the front there's a cutter head in there. So that is excavating the soil at the front. And then if I back up again, that cutter head is at the front of the yellow pipe there. And then this frame on the left side picture, there's a jacking frame. So the cutter head at the front excavates the soil, and then the jacking frame pushes everything forward. So in conjunction, those two forces install the pipe across underneath the road. They usually will cut, so on the left side, you can see they haven't cut out the plate at the front of the shaft yet, but then on the right side they have, and some soil has run in. The big challenge that ended up thankfully not being a challenge on this project was that just to the left of the picture on the left, outside of the frame, there's a pretty big new high school that was constructed. And in the construction of that school, just before this project, the contractor for that project pulled out several large boulders, like 3, 4, 5 foot diameter boulders. And as you might guess, it's kind of a showstopper for any new installation trenchless method. So we were worried about that, which is one reason we went for such a large casing here. I think I'm remembering now, it's a 56 or 60-inch pipe, so you don't necessarily need an 84-inch casing. That's a bit much larger than what you're going to put inside it. But oversizing it would help this contractor, the trenchless contractor, to be able to remove, like go in the pipe, break it up with a jackhammer if needed be, break up the boulder if need be, and bring it out. So that's kind of how we addressed the potential problem for this project.
So the reason you went with such a large, I'm just trying to understand, such a large casing, even though the pipe size was much smaller, was specifically because if you had run into those boulders, that you said that with that new high school built, that the larger casing would have been able to push them through essentially or break them up?
Yeah, like ingest them maybe if they were small enough, or
Okay.
it's large enough that a person like that crew guy down on the left there could go in the casing, like whatever has been installed to that point,
Yeah.
and and break it up and pull it up.
Okay.
Yeah.
So how deep is this trench right here? That looks deep.
It's about 20 feet deep, I'd
Okay.
say 20 feet deep. Yeah. So this one actually is not super deep. We try to get at least 2 pipe diameters under the road. You can see this one is a little more is better. And then it's always a big puzzle to work out, and a balance of all these different factors to figure out like what the alignment will be, what the depth will be, what the method will be. So deeper is usually better, but also you want to target good, like look at the boring logs and target soil layer that looks ideal if possible. So yeah, 2 boring diameters is kind of the minimum to prevent settlement. And we also had, I don't have any really pictures of this, but well, maybe actually the guy, there might luckily be a little tiny surveyor in the top right of the left side picture. Just managed
Oh,
to
I
snag.
see him.
We did, or the contractor had a surveyor coming out every day to measure some monitoring points, settlement monitoring points, to make sure that the road wasn't settling, because this was, as you can see, an active road during construction. So, which is the benefit to trenchless, so you can keep things open. It's often a little more expensive than open cut. I don't really know how it compares actually to rehab, but usually you're putting in a new pipe. So you're comparing an open trench installation to trenchless installation. And trenchless is usually a little more expensive. There's obviously a lot more involved here, but it has a big benefit to the community in that you can keep roads open, you can keep business accesses open and stuff like that. So
Yeah, that's similar to pipe rehab as well, Diana. Like we look at the overall cost where like maybe the pipe and the construction might be more expensive, but you have to look at the cost of permitting to close down a road, to detour it, to have flaggers. With
yeah,
with rehabbing and trenchless repair, we avoid all those additional costs. So then when you actually weigh it out, a lot of times rehabbing a pipe is way less expensive than rip and replace a pipe.
yeah,
But there are times, and I think a couple of my sales guys are on here. It's unfortunate that we get the call too late to come look at the pipe, and there's very little that can be done other than maybe something like this where you do come in and you have to just literally bore out the old pipe because it's so collapsed or it's so far gone and the road is compromised and the potholes is already, they're so great that we can't save it. So
yeah, yeah. Yeah, very similar in that way. Then I talked to a contractor a few months ago who was doing a similar, well, he was pipe ramming, which is a different method than this, but it's pretty simple if you can imagine it. 2 shafts kind of like this, and then essentially horizontal pile ramming. So just using the same kind of hammer. And he was using that method to ingest a pipe that, like you say, they couldn't just, it wasn't savable. I can't remember why, but yeah, just installs a new pipe right around the old one and then pulled it out afterwards. Pretty interesting.
we've seen that before. Yeah.
Yeah, cool. So so there was that cutter head at the front. I should put that picture there. So that cutter head, if you'll recall, at the front of the pipe, and then the contractor installs these augers in varying sizes through the casing. So what you're seeing here are casings that are staged, ready to go, getting staged and ready to go on the yard there. And they put these augers inside the permanent casing to remove the cuttings from the face, and they pull them back to the pit where they can be removed.
And that's the yellow that we're seeing there.
Yeah, on the right, it's the yellow from the side. They haven't quite connected those.
So what's the pipe, the actual pipe product inside the yellow? Is that the pipe?
So
Is
when
that
they're finished with the casing installation, they'll remove the augers, and then the contractor will reuse them for another project, and the casing remains, and then they'll install a final product pipe inside it, and it could be HDPE, it could be Hobos or fiberglass. It's usually not concrete, but you could install something like that.
yeah,
PVC is
okay.
ductile iron.
Okay. I was just
Yeah,
curious.
kind of anything you want, but the steel, you have to use a steel casing for this method because just about anything else would get torn up by these augers. Yeah, so yeah, a big yellow auger is towards the front. Obviously, they use a bigger auger at the front to really make sure they're moving spoils away from the face, and then they can get smaller as they move back. So this is one of the first casing pieces that went in, dropped it down into the hole, and then they weld them together. They're usually in 20-foot sections. Looks like the on the back might be a little shorter, but anyway, they're usually in 20-foot sections. So it takes them a while for a large diameter pipe to weld it all together. It's permanently welded, and then the jacking begins again. They use a clamshell. You're seeing the middle there, on a crane in this case, to remove the spoils. They just come back and they spit out the side. It's a little maybe hard to see in this right side picture, but those spoils come back with the auger and then just spit out the side of the machine. And so they very carefully get that clamshell down there to remove those spoils as they come out.
Are you still looking? Is this the right side of slide 4? Is that the one you're still looking at?
Oh, are they not advancing? No, I'm not looking at slide 4.
Oh, okay. These are the
I'm just showing
casing.
you guys the pictures. Okay, so these are the case. I'm so sorry. This is a
No, that's
casing.
okay. I think it just froze up on you.
Yeah, I'll just stay in this mode. These are the casings with the augers inside that I was trying to tell you about. And yeah, on the right side here, the yellow auger you can see from the side.
Oh, I see it now. Okay. It's like a drill bit.
Yeah, essentially.
Yeah.
Yeah. So yeah, and then this is what I was saying. They're dropping the cutter head is on the left. That's at the very front of that yellow casing
Yep.
that you saw. That you see in the
Now
right
I'm
there.
following. I was like, a cutter head. What is she showing us?
Oh no, I'm sorry. Yeah.
Oh, no. Now it makes more sense. Okay. I caught up.
And the whole world is clear. Yeah, and then the casings are dropped in 20-foot sections with the augers already installed there. They hook up the auger and then this is what I was showing you here, and then weld the casing together. And then the auger it's just put together with a pin so they can pull it out at the end and use it. That clamshell is in the middle. They use to remove the spoils. The spoils come back.
Oh, and I see
If you
him
look at
welding. Okay.
yeah,
Yep.
and then just remove it from the shaft. What's next? So then, yeah, let me know if you have any questions. I'm happy to talk about that more. That's the launch side, and then once they get close to the exit side, I moved over. I was inspecting this project, so spent a lot of time over on that launch side, and then when they got close to popping out of the ground here, I moved over to the exit side. So what you're seeing here is the exit shaft or retrieval shaft on the other side, so you can see the cranes that are working over there on the launch side that I was showing you, and they just did kind of a small pit over here to do the breakthrough. So
Yeah.
they pull out that plate that's at the front of the shaft to make sure that the cutter head has a place to go, and then they just keep moving really and pop through. So they've retracted the cutter head a little bit here, and they do that often just to kind of manage the spoils or the cuttings, so the face so you don't get a sinkhole, essentially, is why.
Right.
So it's a little hard to see, but it's back there. This is that same yellow machine front lead pipe that you were seeing from the start. It's just not so yellow anymore after having traveled 75 feet underground. And and they do a lot of digging and keeping things clear. And as you can see, it just cleared the spans for the
So I see the sides of those walls there say Emery and Sons, Diana.
yeah.
That's who I just met with yesterday.
Oh, really? That's cool. Yeah, they were the general contractor.
Yeah.
This is, I guess I could call it, this is Gonzalez Boring, which is a great trenchless contractor down in this area. I think they work all around the Northwest. And yeah, Emery and Sons was the general contractor.
Okay.
It's kind of interesting. This is something I didn't realize before I was working in trench. I guess there are a lot of things I learned, but the general contractor is responsible for the shafts, even though it's the trenchless contractor that's working in them. So especially on this exit side, they want to time it. You don't want this shaft sitting open forever, but you want it to be ready when you need it. So there's a lot of coordination that goes on to make sure this shaft is ready for the trenchless contractor to use it. And
Right.
yeah, this was as far as I know, this was a great project for teamwork. So it just went really smoothly. It was great. Yeah, let me know if you have any auger boring questions. That, like I said, is kind of just a straightforward project. Probably not gonna win any amazing awards, but at the same time, it was a great project because everything went well, and it didn't hit any boulders, so we were all very, very happy for that. The other one I have to show you today is kind of an interesting application for trenchless, at least in my career, for a wave energy project. The Oregon State University is building a wave energy testing facility off the Oregon coast, sort of near Newport, Oregon. And they want what's something that's very cool about this project in particular. There have been other wave energy testing sites, I guess, around the world, but this is one of the first that actually brings any electricity that's generated back to shore to be used, to be put into the grid and used in the local community. So what we were doing with trenchless was installing conduits to bring that power back to shore. They'll be putting cables in it. The trenchless part of this is complete, and they'll be putting the cables in, I believe, this winter, so very soon.
And this was the one that we talked about, Diana, last week. This was an HDD project. Sorry.
Yeah.
I think Diana and I were laughing for a lot of reasons last week when we were talking about HDD. So didn't we wanted to do a poll question with the group to see who knew exactly what that methodology is.
Okay.
I think you have to launch the poll since you got control.
Meeting controls. Oh yes, here we go. Launch. What do you think HGD stands for? I might have already given away the answer at the beginning. But
we wanted to be fun, guys, because we were when you Google it, the first thing that comes up is not horizontal directional drilling.
There's all these.
And I was laughing because Diana said it's hard disk drive, and I said I don't even think any of our computers even still have a hard disk drive.
No. But regardless, go Google HDD and you'll
yeah.
Posts.
Anyway, we thought that would be fun to see what you guys thought. So I think you have to end it and we can just see what people said.
Well, we have a smart crew here. 10 out of 10 said horror.
There you go.
You can share results, it looks like. Funny. Yes, so good job, everyone. This is horizontal directional drilling, and you can see well, I guess kind of half of a machine there on the left side. This was also a cool project for me because it's pretty rare to have two drill rigs going at the same time on the same site, which is what happened here. In the back there's two drill rigs. One is a 1 million pound rig, which means it can pull back 1 million pounds of force when it's pulling. So I guess I should explain. The HGD has, I'll show you this because it's a little more illustrative. HGD has 3 phases, and the first phase is to establish the alignment across whatever. In this case, we were going out to the ocean, but oftentimes you're crossing a river or crossing a big wetland or something like that. So establish the alignment across under whatever the obstacle is. Step one, it's a sort of a relatively small diameter pilot borehole. And then the second stage, which is what's about to happen here, you can see that reamer behind the bit that's already staged on the drill pipe here. So stage two is to ream the borehole to the proper diameter, whatever the design diameter is. And then stage three is to install the pipe in the prepared borehole. So in this case, I can't remember what I was saying, but anyway, there were two million-pound rigs. So usually you pull a pipe back into the hole, and so the rig on the right, for example, can pull back 1 million pounds, which is a pretty big drill rig, and then the other one is I think it's a 500,000-pound rig. So here you can see they're starting the reaming, like I was saying. These are just kind of fun pictures. That's a bunch of engineers and other contractor folks standing around watching the rest of the contractor crew work, which is what often happens on sites like this. This was a really cool project that had a lot of local community involvement, as well as involvement from like state legislators. The wave energy testing aspect and the fact that it was Oregon State University as the owner and the client, they had funding from the funding for the project is coming from US Congress. So there was just a lot of levels of people interested in this project. So it was kind of fun. There were often visitors coming through to see what was happening and to see the project that they've been involved with funding or some aspect of it. So yeah, that's where you kind of see some people standing around in their vests there. Yeah, this is a great crew. This is the HGD company, and they did a really nice job. Yeah, so that's again the drill rig on the left. The challenge in this project was, again, the ground conditions. Although in this case it wasn't boulders, it was clay. The clay or a clay stone. There's a clay stone all throughout this area that it's a little blurry, I'm afraid. Anyway, it's a very fine-grained clay, and it really clogs everything up. So the way we addressed this problem in design, and the contractor was on board, this is actually a design build project, they agreed to bring I'm gonna space on the word, a spinny thing, a special machine to remove the clay particles from this mud. So HGD, let me show you this on this picture. You can kind of see in this pit here, there's a bentonite clay slurry that is super important for any HGD project. It suspends the cuttings from the front of the borehole, and the pressure of that borehole, or of the bentonite slurry, we call it mud, flowing back through the borehole brings those cuttings back to this pit here. It keeps things cool, it keeps things lubricated, it's super important. However, it's expensive to just keep making new bentonite slurry all the time, so it's reused. And the cuttings are cleaned out of it, and then that slurry is reused. However, it's really hard to get the clay cuttings out because they're so fine. So they brought a special machine out to get out this really sticky clay that creates these, it packs off the borehole essentially, and it can clog things. So we usually had to have laborers here. Usually cuttings just flow back out and they get pumped over to the cleaning plant, the mud cleaning plant. In this case, we had people with shovels, like really helping that stuff come out of the hole. So that was the real big challenge here, and it was a slow and steady kind of approach. And
so it looks like they're using HDPE.
Yeah, so this we had two different HGD. We actually had 5 Ultimate HDD alignments here. 4 of them went out to shore, and so I'm showing you 2 different installation operations here. The one on the right is installing steel casing, which is an unusual way to do HDD, but in this case, because we were only drilling from one side, we only had access to one side of the alignment, because the other side was under the ocean floor. They pushed in steel casing, and the contractor developed a pretty innovative method to do that. So that's what you're seeing on the right. On the left, you're seeing, yes, HDPE, and they used a bundle of 4 6-inch HDPE pipes on the left side, and this one was taking the conduits from the landing site just up from the beach across Highway 101 over to a facility where they'll be monitoring the electricity usage and stuff like that. So the one on the left is a pretty typical HDD installation where the pipe is pulled back, and yeah, and using a bundle is becoming definitely more common. More pipe, you've already drilled a big borehole. If you can pull a few more pipes back, that's great. In this case, they're gonna have 4 conduits, so that was planned from the beginning. But sometimes, even if you're just installing a sewer line, or often not a sewer line, usually a water main with this method, sometimes the owner will say, "Can you just pull another pipe back in case we do want to install a communications line or just something in the future?" So
Yeah.
it's becoming pretty common. Yeah, I think that's all the pictures I have for this one.
Awesome. Well, we're right. We're literally right at our time. Does anybody have any questions for Diana? I can always share her contact information. She's here local in Portland, Oregon. Where all are you licensed, Diana, for trenchless engineering?
I'm a licensed PE in Oregon, Washington, California, Montana, Texas, and Idaho.
There you go. So if you guys have any questions for her, questions for me, we will be doing another Reline Live in 2 weeks, right before Christmas. It is going to be a repeat of the one we did 2 weeks ago. We had almost 60 people in attendance, and I'm new to Zoom because I usually use GoToWebinar, so it didn't get recorded. So we are going to give people a second chance on that one. We will be highlighting some unique shape glass reinforced projects in New York and New Jersey, as well as grouting those projects and how to make sure that they are structurally safe. So Dawn LeBlanc and I will be doing that one. If you guys missed it, sign back up, but it will get recorded this time. Thank you so much, Diana. I appreciate this. I think it's always great to highlight different projects, even if they're not necessarily relining, they're still trenchless technologies.
Yeah, thank you so much for having me. This has been...
Thank you, guys. Reach out to us if you have any questions, and this recording will be on our YouTube channel in about 48 hours.
Bye.
Bye. Thank you.